Hello quad folks. Today I'm going to try to take this head disc apart and see if I can recover a little bit of the parts to reuse. This thing came to me a while back in a bag with a whole bunch of other pieces, parts, and somebody had taken a video head apart and once they had it apart, they just stuck all the bits and pieces back down into the old shipping container, which had a lot of this decomposing, rotten foam rubber that just decomposes into a sticky, gooey mess. And of course, you know, the parts, they just sink right down into it over time, and you know, that's bad enough, but the really bad part about that is some of that, I guess the chemicals that go into that foam rubber, when they decompose, it gets somewhat corrosive, and it'll, you know, pit metal and you know, and do bad things to metal surfaces over time. And well, this one looks like it's maybe gone a little too far. It's really too dirty to tell anything right now, although just on the face of things, I can't really see any wear on the bearing side of this disc, which kind of tells me that this was probably a new head. It probably hadn't been run, you know, before it met its end. And so if you had a lot of hours and a lot of time on a head, depending on, you know, how clean things were, you might see. Now this is another head and shaft assembly. It's not unusual to see a few little micro scratches in the finish, you know, after a lot of hours. This one has quite a bit of wear on it. Yeah, you can see it pretty good there. Here, this is like new. Of course, this is the part that's, you know, underneath the shaft, so there wouldn't be any there. So you have this. So that would be normal to see that. And then this part here where you do see some wear, that's the part that would be running adjacent to the air bearing surface on the motor. And So yeah, that's got a lot of wear on it, a lot of hours. But I don't really see any on this disc here. Of course, when we get down into it and start cleaning it up, we'll find out just how good or how bad it is. And if there's just some nominal surface irregularities without any real, hard pits, then we could probably just bring it over here to our stone, our standard flat stone, and lap it a little bit, polish it out flat again, and it may be just fine. We'll see. Now, let's see if we can soak some of this a little bit. And tear into things. I'm not very hopeful. This stuff, once it dries, it's like cement. You have to really scrub it to get it off. It's like glue almost. This is a drum that's been rebuilt by Spin Physics in the past. And how I know that is, if you look here, see, we have one hole in the end of the aluminum shoe, right in the center of the end. That's indicative of a Spin Physics shoe. Now, this would be an Ampex design, and you notice Ampex had two small holes, one in each corner out at the end of the shoe. Let's see. The reason is it's a different type of a tip. The Ampex, that's getting back into the Alpha Seal era. And here's an example. If you can see this shiny part on the end, that's an Alpha Seal tip. You see, it's the tip part is the little part toward the center, and then you have these broad back ends that were used, for epoxying the tip to the shoe for strength and positioning. And well, when you get to the ferrite era, things got a little smaller. You see, ferrite is just a little square piece. And so, one hole in the middle was, I guess, a thing that Spin Physics started doing way back when, because they were refurbishing as ferrite. I don't think they ever did any Alpha Seal refurbishing. Now, CMC, a head tech as it's known now, they were back in the Alpha Seal area, and so they were using this same Ampex tip all the way through, and they even made their Alpha Seal, or their ferrite tips, and the same shape as the earlier Alpha Seal. So they continued to use these shoes that had two holes in the end. And is one better than another? Well, I don't think so. You know, the Spin Physics is my favorite, the one hole in the end. I've never had one come apart. You know, you hear things about G forces and all this stuff, but you know, I'm a little skeptical about all that talk because these things don't weigh anything, hardly. So, you know, if there's anything to that, you can't prove it by me. I've not seen it. But, getting one of these, just a freebie, I guess, and seeing that it was a Spin Physics rebuild, kind of made me want to see if I can clean this up and maybe rebuild it myself, you know, or these tips may be okay. I would be a little bit skeptical about the windings. It seems like that's the part that when these things really get contaminated with that corrosive foam rubber when it melts or decomposes, it seems like that's what I see more than anything. Fails is the copper wire will, I don't know if break is the right word, but it becomes disconnected sometimes, you know, back where it's soldered, or other times up toward the tip itself. And I'm assuming that has something to do with the corrosive nature of some of that stuff when it decomposes. You know, because those little copper wires are tiny, you know, like 2/1000ths, 3/1000ths. And that's not very big at all. Let's see, we'll see if we can take some of these apart, loosen these. Now these are Bristol wrenches. They're not exactly an Allen wrench. Bristol wrench is an Allen wrench that has had some grooves put in the lands, the flat surfaces, and why they did, I don't know. Why it's called a Bristol wrench, I don't know. That would be a good one for somebody to find out about. But these come apart, and you know, they usually have a little brass washer. It's usually around 5/1000ths thick under them. So we have the little Bristol screw and the little brass washer. There's the other one, its little washer. if you'll notice here, you have a what looks like a set screw to the right of each of the shoes. And this is spreading this torsion spring apart. These set screws are tapered from top to bottom, and so as you screw this in or down, it's spreading this apart more and more, and it's moving this shoe to the left. And on this side we have another torsion spring that's opposing tension against this side. And this is only through the torsion spring. See, this is, well, if it wasn't full of the old foam, see the back side or the drum itself is just a hole for it to come through. Let's see, it's a smaller size. And what these do is it lets you set the 90 degrees quadrature between this gap and this gap and this gap and this gap by being able to move these shoes left or right. And you'd be looking at it, you know, with a microscope, looking at the gap in the tip when you're doing this, ideally. Now, if you get good enough at it, you can do it on the machine. It's not impossible, it's just a little bit harder when you do it that way, but you can do it that way, blindly. If you did do it that way, it helps to have a test tape with some vertical lines recorded on it. So by removing these tapered set screws, we're relieving some of the spring tension against the shoes. All right, now let's see if we can take the springs off. Now the springs, they have a little brass washer like the shoes do on top. Beneath here, there should be another little brass washer between this and the drum. Now, I don't know if we can get this off or not. It's probably still under some tension, or it may be stuck there with the some of that sticky foam. Oh, here it comes. It's coming. use something very thin like a knife blade that you can put in there flat and not put a scratch on anything. Alright, so there's the spring, and there's the little shim washer. These are usually about 2/1000ths. Let's see what this one measures. So we got 0, 1, and 2. I don't know if you can see that or not. My camera is not that good. So they got a 2/1000th spacer, little brass shim washer under those torsion springs. Start with just a fingernail to see how tight or how loose it is, and then you can take a little knife blade and just gently pry up a little bit. Doesn't take much. And there's spring number 2. And there's spacer number 2. Alright, so now we have the, we're down to the drum, and then we have our shoes, which have the tips on it. And let's see if we can pull them off the little radial cams. little bit tight. All right. Now, see again, we have the little square tip right there in the middle of the end of the shoe, and we have the one hole. And now, here is a detail right here. You see how each of the 4 places that the shoe mounts, we have a little channel there that's been machined out a little bit deeper, you know, than the surface of the drum, as opposed to well, let's see, one of these. Now this is a drum that has been used for alpha seal tips, and see, it's flat. It has no little place that's been machined out there. Why that is was alpha seal is a cast metal, and it has a certain amount of give to it, not a lot, but a small amount. Ferrite, on the other hand, will not bend in the sense that you would think a metal will bend before it breaks. This is a ferro-ceramic material that's comprised, well, for these heads, it's iron, manganese, and zinc. And it will crack before it bends. It will not bend. And so if you're gluing the tip to the aluminum shoe, and you have any sort of a surface irregularity, now here's a little jig with the aluminum shoe and then the tip right in the end there. This surface has got to be, you know, as flat as this surface in every way. If it isn't, then the tip may be a little higher on one end or the other. And if you go to clamp that shoe down on a drum such as this that has no relief slot, it's just flat, and if there's any difference there and you tighten that screw down, it will crack the tip. If it comes in contact. And you know, when I first started doing this work, we ran into that a few times, and we kept wondering, why is our tips cracking? Some of them crack and some of them don't crack. And then we realized, you know, well, maybe that's why there's a relief slot that's been machined into some of these drums, is for the use with ferrite to more easily, you know, use the ferrite, you know, so you don't have a stress point and cause it to crack. And so ever since we started looking for that, you know, I've never had any more trouble with cracking ferrite. And so this is I would imagine a drum that's been reworked, you know, an original Ampex that a refurbisher has probably put it on a milling machine and milled that little relief slot to utilize it a little bit better for ferrite use, and instead of the alpha seal. Ampex, they never did use ferrite for quad head replacement, only for experimental purposes. They always had used the alpha seal for their tips. Now later on, I don't know if that held true or not, but every one that I've ever seen was alpha seal. And my friend Bev, he backed that up one day, and with his recollection that he didn't think that Ampex had ever used ferrite on a quad head other than in an experimental capacity. They had always used alpha seal to rebuild their or refurbish their heads with. But now here is an example of an Ampex drum that had been reworked for ferrite that my friend Bev had gave me out of his collection one day. And these tips here are these are ferrite tips, and I don't know how good you can see this on this little puny camera, but you know, if you look at it from the side, you can see they're kind of a dull charcoal looking gray. If you look at it dead on, you may not be able to tell the difference, because if it's polished and lapped, it's going to be like a mirror, and it's going to reflect whatever, you know, is in the light path, and it may just look shiny just because of the light. But if you can turn it over on the side and look down near where the epoxy is, you can usually see whether it's shiny metal, alpha seal, or if it's a dull gray ferrite. So this was a drum that he had gave me. That was one of their experimental pieces there at his time at Ampex, that they had actually put some ferrite tips on, and they had channeled it and put a relief slot in for that to have clearance on the back side of the tip itself, the ferrite, so you don't, have a stress one and cause a crack. So anyway, that's enough for today, and I'll take this in our next little video and I'll soak this on down, and we'll go over to the standard over there and do a little lapping and polishing and see if this will come back to a usable state. I know it looks pretty horrible now, but looks can be deceiving sometimes. We'll just have to follow it on out to the end and see what we come up with.